Unit 4, Day 5. This is Mr. McGough up in R12. We're going to start looking at applying the HK format to any function. So first we're going to take a look at this graph f of x. Here we see the vertex, which is at the point where x equals -2 and y equals -4. We take a look 1 to the right, it goes up 1. 2 to the right, it goes up 4. So this is a non-stretched, non-compressed parabola. So x squared shifted left 2, down 4. G of x is also a quadratic function. And here we see, as we recall, it's x minus h plus k. So h is 6 and k is -4. So that's our new vertex. It is shifted right 6, 1, 2, 3, 4, 5, 6, and down 4, 1, 2, 3, 4. And then it would still be our parabola. So all we've really done is we've shifted function f of x right by 8. So the functions do not have the same vertex. The minimum value is the same. When we put in -2 for x in f of x, we get out -4 for our function value. When we put in 6 for x in g of x, we get out -4 for our minimum value. So the minimum value is the same. Moving on. On your next page, state whether the function is increasing or decreasing. So we'll use our highlighter. I will use green for increasing and red for decreasing. Feel free to use your own highlighters too, by the way. So we see, if I zoom in a little bit, here is where things change. So to the left of x equals -8, from -infinity to -8, this function is decreasing. From -4 to 0, also decreasing. All these are in relation to x. Where is it increasing? Well, from -8 to -4. You'll notice I'm using parentheses, not the square block, because actually at these points, it is neither increasing nor decreasing. It is switching from one to the other. So our other positive, or our other increasing portion of the function is from 0 to +infinity. So let's take a look at our answers. Increasing from -8 to -4, and from 0 to +infinity, and decreasing from 0 to -8, and from -4 to 0. So our answer is D. The next thing you'll see in your notes is this box with all of the possible outcomes of what's happening with our function. A couple of things that aren't shown here. B could also be positive or negative, and there may be a power that's applied to this function, like, say, squared if it's a quadratic, or this inside set of parentheses could end up being an absolute value. We've done some of those as well. But let's talk about these different adjustments from a parent function. So first, we know out in front of A, if it is positive, it's going to open up. If it is negative, it's going to open or point down. If the absolute value of A is greater than 0, well, if it is 0, that whole function will get negated and just be y equals k. So if it's greater than 0 but less than 1, we will end up vertically compressing, or it's called a vertical compression. that means that instead of our regular function, I'll just use the absolute value as an example, it would make it kind of flatter. For the same values of x left and right, it won't quite reach as high of a level. If a exactly equals 1, no change from our parent function. If a is greater than 1, it will cause this function to get tall and skinny. So that's called a vertical stretch. For b, well, b is a little bit different. We haven't really talked about b yet. Well, first off, if b, oh, shoot, I forgot to say, opening up is the normal one. Opening down means it would actually reflect the function over the x-axis. So in other words, you would go from being one of these red functions to flipping it across the x-axis and making it point downward. If b is negative, it'll actually flip it over the y-axis. So our function for b would cause it to flip over the y-axis. On the other side of things, if b is greater than 0 but less than 1, it's going to cause what's called a horizontal stretch. So, from our parent function, a horizontal stretch would take our x values and stretch them out horizontally. If b equals 1, no change. If b, absolute value of b is greater than 1, it'll do what's called a horizontal compression. Horizontal compression would then squeeze the sides in horizontally. So a horizontal compression will look a lot like a vertical stretch, but mathematically it's actually a little different. And I'll attach a link to a YouTube video at the bottom down in the comments. I'll go ahead and write it down here for you in case you want to look it up. https://youtu.be and then /259 big L big U little I little n capital J 8 minus little w. Great little video. Goes over stretches and compressions, both horizontal and vertical, with some good graphing and some good examples. Now, x minus h. We discussed that h is always considered to be a positive number here, and x plus h really means x minus negative h. So if it's x minus h, h is a positive number, and this would mean shift right. X minus negative h, shift left. K, if k is positive, we will shift up. If k is negative, we're going to shift down. Let's take a look at some examples. So first, 7 times x plus 2 quantity squared minus 3. What do we know about this? The parent function, it is a quadratic. A equals 7. A is greater than 1. It is vertically stretched. We have x plus 2, so that means it's x minus negative 2. So h is negative 2, and therefore we shift left. When I say shift, by the way, I'm talking about the vertex and everything else, but the vertex is kind of what you're focused on. And then minus 3 at the end means we shift down. So shift left 2, down 3. On number 2, here we have an absolute value function. As the parent function, we see a out in front of negative 0.06. So that means it's going to reflect it over the x-axis, or it will open downward, and then it is going to vertically compress it by 0.6, because that absolute value of a is less than 1. X plus 5 is x minus negative 5, so it will shift left by 5, and it will shift up by 9. Feel free to put these in your calculator. Put in the base function, the parent function, as well as then after you put in your parent function, on the same graph, instead of removing that first function, so like for this one, you'd put in absolute value of x, plot that, graph it, and then put this one in as y equals and hit graph, and you'll see both of them on the same grid, and you can see what's really happening. On number 3, we always want to have x by itself. By the way, the parent function, if it's just x, is linear. So inside of 2x minus 3, we have to figure out what's happened to x. Well, it's been multiplied by 2. So it's really 2 times x minus 3/2. That gives us that value b. So b is positive, so no change to its y-axis relation. And it's 2. Which is greater than 1. So this is horizontally compressed. By a factor of 2. Now I had to do that before I look for h. But also I'll take a look out here at a, and a is also greater than 1. So that means it is vertically stretched by 4/3. So it's both horizontally compressed, got a little bit skinnier, and it got vertically stretched. So it got skinnier and taller. And then we take a look at h, which is now negative 3/2. So it's minus h. So h is positive 3/2, so that means it is shifted right by 3/2. And then at the end is our k, so it is shifted up by 4. Let's move on to the next page. Number 4. Negative 3x squared. So first we see it as a quadratic function, or parent function of x squared. We see that a is negative 3, so it's reflected over the x-axis. In other words, opens downward. And it is vertically stretched by a factor of 3. So pause the video for a moment and try number 5 and number 6 on your own. Write down your answers, and when you restart, I'll give you the answer. So go ahead and pause. Okay, welcome back. And now, the first thing we have to do, we recognize that this is a cubic function with that power of 3. And then we look inside of our parentheses. We have 3x minus 2, so we can only have an x in there, because the cubic function parent would be x cubed. So we have to factor out a 3. I'll rewrite this: 1/2 times 3 times x minus 2/3, all of that cubed, plus 7. So b, 3, greater than 1. So it's horizontally compressed by a factor of 3. A, 1/2. It is vertically compressed. So it gets skinnier and shorter by a factor of 1/2. And then h is x minus h, so it is shifted right by 2/3. And then we have a plus 7 at the end, so it is shifted up 7. Last one, number 6, absolute value. Sorry, my pen's not quite touching the page every time. And then we'll take a look at what's happening to it. A is 4, so it's being vertically stretched. By 4. X minus h, so x minus -5, so this is a shift left by 5. Plus 9, so plus k, and shift up by 9. Seven through 12, similar process. Now you're describing the transformation. X minus 2, I have shifted right, x minus h, by 2. So that takes the entire original function, g of x, and shifts it right by 2. Number 8, this would be on the end, so this is a shift up by 1. F of x plus 6 means it is shifted, well, that's x minus -6, so it's a shift left 6, and then minus 4 is down 4. Number 10. Go ahead and pause. Try 10, 11, and 12 on your own when you restart. I'll walk you through it. Okay, so number 10. F of x plus 8. Well, it's x minus -8, so this is a shift left by 8. And then we have this 6 out front, which is our a, so it means it is vertically stretched by a factor of 6. Number 11, h of 3x. Well, this would be our b. So that means it is horizontally compressed so made skinny by a factor of 3. And then we have negative or -1 out in front of the function, so that means it is flipped or reflected over the x-axis. The last one, kind of complicated. This is the first time we've seen where b, we've factored out a -1 from our function. So this does reflected over the y-axis. So again, if we talk about where this would be, it would then be reflected over the y-axis. Then 1/2 out in front, so it is vertically compressed by a half. And then our shift, x minus 1, so it is shifted right 1 plus 7 plus k, so it is shifted up 7. When we take a look at a couple of graphs, first off, you'll see that the instructions say that the graph, the original graph, is through the origin. So the red graph on this first one is our original. We're going to look for where this vertex, this twist point, occurs on the blue graph. That's here. First, we have to figure out what the parent function is. Well, let's see. When x is 1, well, when x is 2, y is 2. When x is 3, y is way up here. Well, that's not. Wait a minute, that's 1. Oh, we have to look at the scale. Notice, our scale is not just 1 square is 1 square. So this point is actually the point 1, 1. This point at 2 is actually up at 2, 8. This is a cubic function. And on the negative side, a negative times a negative is a positive, but a negative times a negative times a negative gives us a negative again. So we can see that this is a cubic function. Now we're going to look at the transformation. First, is there any scaling that occurs? Well, from 4, I'll go right 1 and up 1. 4, 3, by the way. So the scale has not changed. Hasn't reflected over the x or the y-axis, and the scale hasn't changed. So both a and b are just 1. Good news. Now we're going to look at the shift. So from the red graph, I would go right 4 and up 3. So that means it would be x minus 4 cubed plus 3. Right 4 up 3. Number 14, again, we're going from the red graph to the blue graph. We'll take a look at what happens over a course of 1. No change. Well, correction. It's flipped. So, red is upward. The blue graph is facing downward. So the first thing we can say is a equals -1. It is reflected over the x-axis. When that occurs, I would get the graph that looks like this. And then I need to move that. Again, looking at my scale, I would move it 1, 2, 3, 4 to the left, and then 1, 2 up. And I suspect, but I can't really tell exactly from the graph, that it's probably the 4th power. It's definitely an even power, because everything becomes negative times a negative times a negative times a negative would also be positive. And it's really flat in here. So I can't tell exactly, but we do know, may not know what the parent function itself was, but we know it's been done to it. It's been reflected over the x-axis, and then it's been shifted 4 to the left and up 2. So, again, I'll post the link, hopefully, if I can figure out how to use the YouTube, I'll post a link to that second video that goes over compression and stretches, vertical and horizontal as well. But feel free to go back, take a look at the examples, particularly on that first page, that big graph. Make sure you take a look at that and you kind of think through what all of A, B, H, and K are all doing. Thank you.